All right, guys. So the last video I made for you, we made the following notes. We talked about the phases of the moon, how the moon's appearance changes over time, but we know the moon doesn't actually change size or shape. It's the moon. We just see different parts of it lighted by the sun. And that pattern is going to repeat in a cycle over and over, approximately every 1 month or approximately 28 days. And we drew these drawings about what the phases of the moon looks like and how they're named, where waxing means they're getting brighter, waning means they're getting dimmer, and then each of the shapes, crescent, quarter, and gibbous, are named, and then we can figure out what the name of each of these positions is. For example, 6 is a waning gibbous moon, 3 is the first quarter, or you could say the waxing first quarter, and so that's what we call the phases of the moon. Today, I want us to focus on why the moon has phases, why it looks different at different times of the month based on where we are on Earth. And so we are going to, in this part of your notes right below that, we are going to draw a model that you can use to explain why the moon has different phases at different times. So to set this up, the first thing we need the sun. And the sun is going to be so far away from the Earth that we're not going to draw it, but its rays, its light definitely serves a huge purpose in this. So here, right on the other side of the red line here in your notebook, we're going to draw the word sun. And we're going to draw those light rays because they come in at straight lines and strike the Earth and moon, because we said it's so far away that only the light that's aimed directly at the sun, the Earth and moon is going to make it. So the sun's rays are coming from this direction. We're going to draw the Earth right in the center. This is Earth. And we're going to be looking down on top of Earth's North Pole. So N equals the North Pole. So the view we're about to draw, imagine you are standing, floating in space, looking down upon the North Pole of the Earth, and the moon is going to be orbiting around that Earth from that position. So we're going to draw 8 phases, and I'm going to start by drawing the ones that, we talk about the points of the clock. So like draw one at noon, and one at 6, and make them pretty big. I realize that's the same size as the Earth, but it's going to help us see. So make sure they're plenty big. One at 3 o'clock and one at 6 o'clock. And then we're going to draw positions between each of these. So not perfect, but we've got 8 positions here. Now, just like day and night on Earth occurs, because the sun is shining on one side of Earth. And so I'm switching to a pencil here. I think that's going to be helpful. If you can, and you were using pen, please switch to pencil, because if you get it wrong, it gives us a chance to erase. It's also easier to shade. So when the sun strikes the Earth, half of it is going to be lighted, half of it's going to be nighttime. So we're going to shade that in like that. And that same thing happens to the moon in each of these positions. So we're going to divide the moon in half in each of these positions. The half that is closest to the sun is going to be lighted. The half that is farthest from the sun is going to be in darkness. So this is the night and day on the moon. Just like the Earth, the moon has night and day. It's only lighted on one side by the sun, and the side that's away from the sun is going to be in shadow. And so now we have the Earth and 8 positions of the moon all shaded exactly the same, because you're getting sunlight from one side and the other side is not getting that sunlight. It's going to be in shadow. So let's start by looking at this position right here. I'm going to be rotating my paper. I think you should rotate your paper, because it's easy to, when you see things there in front of you. So we're going to be talking about our vantage point looking at the moon, because we're going to be in space for our drawing, but to see the phases of the moon, we see the phases of the moon from Earth. So we need to turn our paper so that we are looking at the moon in front of us. So we want to start with this moon right here. And we're gonna be on the surface of the earth looking at this moon. So I'm gonna draw a little dot to show me this is where I'm standing. I am looking this way. So my view is this way at the moon. Can you see the back of the moon? No, it's on the other side. You can't see around to the back of things. If I were to show you a globe and ask you what's on the back of it, you couldn't show me because you can't see it when it's behind you. I'll show you. I've got a globe. What am I pointing to on the back? You have no idea because you can't see it. You can only see this half. So we can only see the half of the moon that's pointed towards us. So when we're on Earth looking this direction, we can only see this much. So we're drawing a sight line. Anything behind that line we can't see. So the side of the Earth that's facing us, how much of it is lighted? None. It's completely dark. It's completely shaded. So this is going to be a phase of the moon where we don't see any of the lighted side. What would that correspond to on our original drawing? A side that was completely shaded. That's going to be the new moon. So in your model, this is going to be the new moon. This is position 1. Because the half of the moon that we can see is completely in shadow. Which way does the moon orbit? Counterclockwise. So let's move counterclockwise to our next position. This is going to be position 2. Rotate your book so that position 2 is directly in front of you. We're going to be here looking that way. So we can only see the half of the moon that is closest to Earth. So when we look at the moon, the part that we can see, it is mostly in shadow and a little bit of light. So I'm going to color that to show what we actually see versus what the whole moon looks like. So it's mostly in shadow, has a little bit of light, and that light is on the right-hand side. So let's look at our model over here. Position 2, mostly in shadow, a little bit in light, and that light is on the right-hand side. So this corresponds to the waxing crescent moon. So we're going to name it that. The waxing crescent. Just like that. Let's try the third position. We've got our view from Earth. We have a sight line that runs like this. The part that we can see is half in shadow, half in light. The light is on the right-hand side, just like this. Half in shadow, half in light. The light is on the right-hand side. This corresponds to the first quarter, just as we expected. What I'm going to do is pause the video. I want you to pause the video, and I want you to try your best to figure out the rest of these, see if they match the other, and then come back and double check if your drawing looks like mine. Give you a peek at what I have so far. I've done a few of the steps. We'll keep going. I'm going to pause again. All right, so here is my finished drawing. I have shaded in pencil the part of the moon that is shaded completely, half, always half. What I have shaded in ink in purple is the portion we see from the Earth that's shaded. So what you'll notice is we have that same pattern, mostly shadow, a little bit of light, about half light, more than half light, a little bit of shadow, and then full. And then it starts waning again, a little bit of shadow, but mostly light, half light, half dark. So you have that quarter moon, a little bit of light, but mostly shaded for a crescent, and then back to that new moon again. So the positions of the sun, the earth, and the moon relative to each other cause the visible side of the moon to be covered in different amounts of night and day, different amounts of shade. And so it's based on the angle formed by the sun, the earth, and the moon. Different angles, different amounts of shade can be seen. Another thing that I find interesting, just a little bit of bonus, have you ever noticed that you see the sun, the moon, sometimes when the sun is still out? Do you see how these views of the crescent moon and new moon are on the lighted side of the earth? That means when the moon is highest overhead, it's actually daylight outside. So that new moon is highest in the sky at noon, right in the middle of the day. The crescents are going to be high in the sky in the morning and in the evening. The quarter moons are going to be highest in the sky right at sun up and sundown because of that day-night line being right there. And the larger moons are highest in the sky at night when it's dark. In fact, the full moon, it's going to be around midnight when it's biggest and highest full up in the sky. I think that's kind of a neat thing that you can see in this drawing that you might not know. You are going to be asked in the upcoming days to be able to predict what phase of the moon a certain position of the sun, earth, and moon would cause. So I'm going to give you an example on a piece of scratch paper. Hold on just a second. So here's my scratch paper. What if you got a drawing of the sun, earth, and the moon? This is the moon. It's little. And I ask you, based on this drawing, what phase of the moon is it going to be? What would you do to figure that out? Hopefully, you'd check the model that you have, and you'd use your understanding of how we made that model, and you would be able to decide if the sun is here, that's similar to the sun being here, the earth is here, and then this moon is directly below the earth. So in this situation, that would be this position. So I would predict this would be the first quarter moon. What if you got a drawing like this? Where the sun was here, the earth was here, and the moon was here. This looks a little different than our model. So what you would need to do is to be able to rotate these two so that they're pointing the same direction. The sun, the earth, and the moon, the sun, the earth, and the moon, you'd be able to predict. This is a waning gibbous. Does that make sense? One of the neat things about this is if you're not sure and you're having trouble doing your rotating and thinking, another way to double check yourself is by looking at the angle that's formed by the sun, the earth, and the moon. So think big, middle, small. Start with the big, then go to the small. So if I draw an angle from the center of the sun to the center of the earth and then to the center of the moon, in math class, you draw angles. What kind of angle is this? Is it an acute angle? Is it a right angle? Obtuse? Straight? Hopefully you recognize this as an obtuse angle. Obtuse angles are always going to be gibbous moons. Now, you have to figure out if it's waxing or waning based on its position, but an obtuse angle is always going to be gibbous. If you do your sun, earth, moon angle and you get an acute, it's always going to be crescent. Sun, earth, moon angle is right. It's always going to be a quarter moon. You just have to figure out if it's going to be waxing or waning. And then if you get a straight angle, it's going to be full or new. You're going to get some opportunities to practice with this on Thursday.